Okay, so here are the homework problems. The first two or three, let's see what the third problem here. Yeah, the first three just verify that the x values are solutions of the equation. So what that just means is you plug in the values into the equations and see if you get the result, which is 0. And I guess in all of these cases it's 0. So what we do is we have the cosine of pi over 3, which is the first question, minus 1 equals 0. And so if you go to your unit circle, pi over 3 is this angle. There's pi over 4, pi over 6. And if we have the unit circle, what you see is the x-coordinate is going to be a half. If you look on your unit circle, it has 1/2, comma, square root of 3 over 2. So the x-coordinate is a half. So you get 2 times the cosine of pi over 3, which is a half, minus 1. And 2 times a half is 1. So 1 minus 1 equals 0, which now is equal to 0. So that verifies. So the same thing for the second part. You have 2 times the cosine of 5 pi over 3 minus 1 equals 0. So where is 5 pi over 3? Well, if you think about 6 pi over 3, that's 2 pi. So it's going to be the same as the one we just looked at, except it's going to be in the fourth quadrant. But you can see both pi over 3 and 5 pi over 3 have the same x-coordinate. They have the negatives of the y-coordinate. This is positive, the square root of 3 over 2, and this is negative, the square root of 3 over 2. So for our case, we're looking for the x-coordinate, which is a half. So if you do the cosine of 5 pi over 3, it's going to be half. Subtract, so we get 2 times a half minus 1. 2 times a half is 1, so you get 1 minus 1, which is 0, which again equals the right-hand side, which is 0. So both of those are solutions. Now if you were to do this using your calculator, you just plug them into the equation. You just have to make sure that that you have your calculator in radians, because these angles are radian degree measures. Okay, the next one, 3 times tangent squared of 2x minus 1 equals 0. So one solution they're saying is pi over 12. So you take 3 times the tangent of 2 times pi over 12 squared minus 1. Now you'll notice the difference here is that it's the tangent of 2x squared. That's what tangent squared means. It means tangent of this, tangent of 2x, the whole thing squared. So we have the tangent of 2 over 12, which is 1/6. So you get pi over 6. Tangent 3 times the tangent of pi over 6 quantity squared minus 1. And if you remember tangent, it goes 0, square root of 3 over 3, 1, square root of 3, undefined. Those are the 0, pi over 6, pi over 4, pi over 3, pi over 2. Those are the numbers. So the tangent of pi over 6 is the square root of 3 over 3. So we have 3 times the square root of 3 over 3, quantity squared, minus 1. If we square the square root of 3, we'll get 3. And if we square 3, we get 9. So the square root of 3 squared is 3. So the square root of 3 squared is 9. And you see I get 9 divided by 9, which is 1. 1 minus 1 equals 0, which is equal to the right-hand side. So this is the right-hand side. This is the left-hand side evaluated. So that verifies that pi over 12 is a solution. And then we can do B. So we do the same thing. 3 times the tangent of 2 times x, which is 5 pi over 12, quantity squared minus 1, which is the left-hand side. So we get 3 times the tangent of 5 times 2 times 5 is 10. 10 twelfths can be simplified down to 5, 6. So this becomes 5 pi over 6. 2 twelfths is 1/6. 5 pi over 6. Okay. Now what is the tangent of 5 pi over 6? Well, let's look at that. Where is 5 pi over 6 on our unit circle? Well, it's right over here. You can look that up on your unit circle. 5 pi over 6. And if you remember, the previous problem was pi over 6. 5 pi over 6. These both have the same reference angle. The reference angle is pi over 6. So this is also pi over 6. The only difference is that, remember, all students take calculus. So in the second quadrant, 5 pi over 6 is in the second quadrant. So the tangent is going to be negative. So we'll get 3 times negative the square root of 3 over 3 squared minus 1 equals 0. But when you square a negative, you get a positive. So we'll get 3 from here. The negatives, two negatives become positive when you multiply them together. The square root of 3 squared is 3. 3 squared is 9. And finally, 9 divided by 9 is 1. So you get 1 minus 1, which is 0. That's the left-hand side. That equals the right-hand side of the original one, which is 0. So that verifies the second problems being solutions. What this is kind of telling you is when you come up with your answers in subsequent problems, you can check your answer by just plugging it back into the equations, like any solution problems that we've done. You can always check your answer. Okay, number 3, you've got 2 times the sine of x squared minus sine of x minus 1 equals 0. So again, what I've done is I've rewritten the sine squared of x as the sine of x squared. So now we can plug the value in there. The sine of pi over 2 squared minus the sine of pi over 2 minus 1. Again, what's the sine of pi over 2? Well, pi over 2 is the positive y-axis, and the unit circle, the coordinates are going to be 0, 1. And the sine is the y-coordinate. So we get 2. So now plugging that in, so we know the sine of pi over 2 is equal to 1. And again, if you did this in your calculator, making sure you had your calculator in radians, you get the same answer. So you have 2 times 1 squared minus 1 minus 1 equals something. We're evaluating the left-hand side and verifying that it is 0. So you get 2 times 1 squared, that's 2, minus 1 gives you 0. So that's the left-hand side evaluated and simplified, and that equals the original right-hand side, which is 0, and therefore you have verified the solution. And then, okay, so we're going to do the second part here, which is x equals 7 pi over 6. I actually did this problem one time. First time I recorded it and did it wrong. I forgot to square this part, but so the sine of 7 pi over 6, if you go to your unit circle, it's this line, which is the closest one to the negative x-axis. And if you draw over to the y-axis, you get negative 1/2, which is the sine. And if you go up, you get the cosine is negative square root of 3 over 2. So it's negative 1/2. So if we plug that in, we have 2 times negative 1/2 quantity squared, which is what I forgot to do last time, minus 1/2 minus 1 equals 0. So if we square this, we'll get, oh, this is negative 1/2. It's like, it's not working out. So the sine of 7 pi over 6 is negative 1/2. So here, when we square negative 1/2, we get positive 1/4. Here we get a negative times a negative, so that becomes positive 1/2. Minus 1 equals 0. 2/4 is a half, so we get a half plus a half minus 1, which is 0 on the left-hand side. Half plus half is 1. 1 minus 1 is 0. So that is a solution. Not all of them were verified, because not all of them were solutions. Okay, so the next bunch of problems, we're asked to solve the equations, which means we need to find all the solutions. So this is where we find the solutions between 0 and 2 pi, and then we add the appropriate values, depending upon whether they're sine or cosine or secant or cosecant, or if they involve tangent and cotangent. So there was the rules that if they're sine, cosine, cosecant, secant, you find the two solutions between 0 and 2 pi, and then you add n 2 pi, plus or minus n times 2 pi, or plus n times 2 pi if n goes from negative infinity to positive infinity, integers. So let's do a start with number 4. So what we want to do is we want to solve for the sine of x. So first thing you would do is you would subtract 1 from both sides. That goes to 0. That becomes negative 1. Or you can think about moving positive 1 to the other side. It becomes negative 1. You divide both sides by 2, so you get sine of x is negative 1/2. Okay, so that's the first thing you need to do. Get it into something. Sine of x equals something. Cosine of x equals something. Tangent of x equals something. Now, instead of using the unit circle, we're going to use our calculators. And this is all going to be in radians. So make sure your calculator's in radians and don't change it for this. So the way that we're going to do this is we're going to find the reference angle, or the reference x. And then we'll use all students take calculus to figure out which quadrant they're in. We'll find the solutions between 0 and 2 pi, and then we'll add the appropriate result here. So first, step number 1, that was step number 1, solve for the trig function. Step number 2 is find the reference angle. So I'm going to call it x prime instead of theta prime. So that is the appropriate inverse trig function, in this case the inverse sine of negative 1/2. But besides negative 1/2, we take the absolute value of that. So the reference value, reference angle, is the inverse sine of positive 1/2. The absolute value of negative 1/2 is positive 1/2. Okay, so let's plug that in our calculator. Inverse sine of 1/2. And what I will get is 0.523 radians. Now this is where we convert this to some multiple of pi. So we're going to take this number, 0.523, which we already have in our calculator, and divide by pi, multiply by pi. Okay, so the reference angle is that, 5.5235 divided by pi, and I get 0.166 pi, or pi over 6. Okay, so that's my reference angle in radians. Okay, next thing you do is which quadrant? Q, question mark. All students take calculus. The one I'm interested in here is the sine. So we'll just write the sine down here. The sine is positive in the first quadrant and positive in the second quadrant. That's because they're all positive in the first quadrant. That's why I always get a positive. That's why the reference angle is always in the first quadrant. Sine is positive in the second quadrant, hence it must be negative in the other two quadrants. It's always positive in half of the quadrants. So the answer is, since since we have the sign of negative 1/2, so this negative here is going to tell us that it's a quadrant 3 and quadrant 4 solution. Okay, so once you know that, you use the appropriate equation that says in the third quadrant, it says the angle, which I'll use x in this case. X in the third quadrant is the reference angle, pi plus the reference angle. Okay, pi plus the reference. So I get pi plus pi over 6, which is 6 pi over 6 plus pi over 6, which is 7 pi over 6. So that's the third quadrant solution. And then the fourth quadrant solution is going to be x is equal to 2 pi minus the reference angle. So I get 2 pi minus pi over 6, and 2 pi is 12 pi over 6, because I'm trying to get 6 here, so I'm finding a common denominator, minus 1 pi over 6. That gives me 11 pi over 6. Okay, check your answer here. So all we have to do is take the sine of 7 pi over 6, plug that in your calculator. It's in radians. Sine of 7 times pi divided by 6, and I get negative 0.5, which is the same as negative 1/2. So check, that one's right. The second case, sine of 11 pi over 6, and I'm going to require you to always check your answers. So I'm going to get in the habit here. So 11 times pi divided by 6, and I get negative 0.5, which equals negative 1/2. So check again. So those are my two solutions. So I can write that out. My two solutions between 0 and 2 pi, but not including 2 pi, are going to be x equals 7 pi over 6 and x equals 11 pi over 6. And you might like be, okay, I'm done. But you got one more thing. And so to get all solutions, you say x equals 7 pi over 6 plus 2 pi times n, where n goes from negative infinity. So we'll go negative 2, well, we'll go to from negative infinity. Let's put it as a set here. So it goes from negative infinity to negative 1, 0, 1. That establishes the pattern that they're integers and they're all of them. And like that. So our solutions between 0 and 2 pi are when n equals 0. The one that are in the next loop are when n equals 1. So that's using that solution. And then you also have the same thing with the other solution. So you have 11 pi over 6 plus 2 pi times n, where n is any integer between negative infinity and positive infinity. Again, the solution between 0 and 2 pi is 11 pi over 6. Okay. So the next one we have is the cosecant. So that's a little different because it's not cosine or sines, but let's just write it out. You're going to do the same thing. So if we add 2 to both sides, we get that. Or if you move negative 2 to the other side, it becomes positive 2. Then we divide by the square root of 3. And at this point, because our calculators only do cosine, sine, and tangent, what I can do is take the reciprocal of this, and the equivalent reciprocal equation would be that the sine of x equals the square root of 3 over 2. Okay, so there we go. So the first step is to solve for this equation. Solve for it in terms of one of the three main trig functions. The second step was to find the reference angle, I believe. Let's go back here. Yeah, second step, find the reference angle. So x prime is going to be equal to the inverse sine again, because this is the sine, so use the inverse sine of the absolute value of the square root of 3 over 2, close parenthesis. Again, this is going to give you an angle between 0 and 2 pi, 0 and pi over 2. And when you take the absolute value of the square root of 3 over 2, you just get the square root of 3 over 2. So we're going to take the inverse sine of the square root of 3 divided by 2, close parentheses, and we get 1.047 radians. But we're going to divide by pi, and you'll get 0.333 pi radians, which we should recognize as 1/3, so this becomes pi over 3. So that's my reference angle. This number should always be between 0 and pi over 2. So that was step 2. Step 3 says figure out which quadrant you're in. All students take calculus. Again, we're dealing with the sine. So the sine's positive in the first quadrant. It's positive in the second quadrant, negative in the third and fourth quadrant. So in this case, it's quadrant 1 and quadrant 2 are your solutions. In our last one, we had negative, so it was in the third and fourth quadrant. So once you have that, you can use the appropriate equations. So in the first quadrant, the angle, which we'll use x, is just equal to the reference angle. So our first quadrant solution is pi over 3. And then our second quadrant solution, x is equal to pi minus the reference angle. So we get pi minus 1/3 pi. 1 pi is 3 pi divided by 3. Again, I'm trying to get the same denominator. So you get 3 pi over 3 minus 1 pi over 3. That's 2 pi over 3. Okay, so that is my second quadrant solution. Again, we're going to check our answer. Check. So if we go back to the original problem, which was the sine of x is square root of 3 over 2. And remember, the square root of 3 over 2, if we plug that in our calculator, is going to be square root of 3 divided by 2 is 0.866. So that's what hopefully we're going to get when we evaluate this. So if we take the sine of pi over 3, put that in our calculator, we get 0.866. So check, matches. And the sine of 2 pi over 3, plug that in our calculator. 2 times pi divided by 3. And something's wrong there. Oh, I did the inverse sign. Sine of 2 times pi divided by 3 is 0.866, which is equal to the square root of 3 over 2. So we've done that right. So that was this was the third step, was to, once you have the reference angle, well, I guess really third step was this, so this is fourth step, which is figure out what the solutions are. And then the fifth step is to find the solutions in all quadrants. So again, because it's the sine function, all we do is we take the answer. So the first quadrant solution was pi over 3 plus 2 pi times n, where n goes from negative infinity to positive infinity. And likewise, we take the second quadrant solution, which is 2 pi over 3 plus 2 pi n, where n goes between negative infinity and positive infinity integers. Okay, so that's that one. Okay, so next one we got tangent. We're going to use tangent ultimately, because that's what we have. So this is 6. So we'd take 3 cotangent of x, quantity squared, minus 1 equals 0. Move the negative 1 to the other side, it becomes positive 1. Divide by 3. Okay, so there we go. Well, almost. One more step is to rewrite it in terms of tangent. So we get the tangent of x is equal to, oh, I forgot the square thing here. So let's do that. So this is squared. So when you take the square root, you get the cotangent of x equals plus or minus the square root of 1 over 3, which is plus or minus the square root, well, the square root of 1 is 1, and the square root of 3 is the square root of 3. And then we can take the reciprocal before we do anything. We don't need to, so we'll get plus or minus the square root of 3. So there's actually two equations, and this happens a lot when you have something squared. So you actually get 4 solutions between 0 and 2 pi instead of just 2 solutions. So we're going to have square tangent of x equals plus the square root of 3, and the tangent of x equals minus the square root of 3. So just going ahead a little bit, this is going to give me a quadrant 1 and a quadrant 3 solution, because the tangent is positive in the first and third quadrants, whereas the tangent is negative in the second and fourth quadrants. So we're going to have all 4 quadrants involved in this solution. And like I said, when you have something squared, that happens a lot. And I should have probably just left this as cotangent quantity squared, cotangent of x squared. It was correct what I had. It's just probably made sense to leave it at that. Okay, so we're going to do two parts. First is when the tangent of x equals the square root of 3. The thing is that these really are going to be so similar. So we're going to have the same reference angle for both of these situations. So if you do, I forgot, it was 2 reference angles, section 2. Yeah. So the first one was to solve these. The second, so that's 1. And then 2 is to find the reference angle. So the reference angle is the inverse tangent of the absolute value of plus or minus the square root of 3. Okay, so I've included the plus or minus here. And when you have the absolute value of plus or minus, you're just going to get the plus part. So we could say x prime, the reference angle is the inverse tangent of plus the square root of 3. And if we plug that in our calculator, we'll get the inverse tangent of the square root of 3, and you get 1.047 radians, and then you divide by pi, so that's 0.333 pi radians, or the reference angle is pi over 3. Okay. So let's add a page. So step 3 is to, we already did step 3, but we'll do it again here. You know, all students take calculus. The tangent. So the tangent is positive in the first quadrant and the third quadrant. It's negative in the second and fourth quadrants. So when I have the tangent of x equals plus the square root of 3, that's in the first and third quadrants. And when you have the tangent of x equals minus the square root of 3, that's going to be in the second and fourth quadrants. So here, the two solutions with the positive square root of 3 is going to be equal to the so x is going to be equal to just the reference angle in the first quadrant. So x is equal to pi over 3. The second quadrant, x is equal to pi minus the reference angle. So you get x is equal to pi minus pi over 3. We just did that a minute ago. So that's going to be 2 pi over 3. So that's the second quadrant solution. Third quadrant solution, the angle is equal to pi plus the reference angle. So we get x is equal to pi plus pi over 3. So that's 3 pi over 3 plus 1 pi over 3. That's 4 pi over 3. And then your fourth quadrant solution is equal to 2 pi minus the reference angle. So we get 2 pi minus pi over 3. And 2 pi is 6 pi over 3. 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. So these are our four solutions right here in the interval from 0 to 2 pi. So 3 was to find what quadrants they're in. 4 is to find the solutions in those quadrants. And then step number 5 is to find all the solutions. So what we do is we take our first quadrant solution and we add 2 pi times n. We take our second quadrant solution and add 2 pi n. And we take our third quadrant solution, which is 4 pi over 3 plus 2 pi n, and our fourth quadrant solution, which is 5 pi over 3 plus 2 pi n. Now I'm going to show you how to do this graphically to get these solutions. So what you do is you take your original equation, 3 cotangent of x squared minus 1 equals 0, plot that, and then look for the x-intercepts. And we'll show it from 0 to 2 pi. Well, we'll show it from 0 to 4 pi, 2 pi first, and then we'll go to 4 pi. Okay, so the equation was 3 times the cotangent of x squared minus 1. Okay, let's just double check that. 3 cotangent of x squared minus 1. Okay. And we want to go from 0 to 2 pi. And we've got the y's here, so we graph it. So that's the function. And if we plot this as a multiple of pi, we'll get this. So the first one is x equals 0.33 pi, which is pi over 3. So that was the first solution. The second solution is 0.666 pi, which is 2 pi over 3. And then we have 1.333, which is 4 pi over 3. And finally we have 1.66, which is 5 pi over 3. So those are my solutions. pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Now if I go to 4 pi, so I've got 2 periods, you see the same thing happen. You've got these 4 solutions, and this solution maps to that one, so you add 2 pi to that. When you get that one, you add 2 pi to this, you get that, 2 pi, 2 pi. It just keeps repeating itself. So in some ways, you know, if you look at the notes, there's this thing about if it's tangent, you add pi to it, but really the reality is if you get the 4 solutions, or the solutions between 0 and 2 pi, you always just add 2 pi to 2 pi n to them, and that gets all the multiples. Okay, number 7. Yeah, we're going to do a lot of these because this is, like I said, probably the most important thing that you're going to learn in this semester. Okay, so the last one here, not the last one, but 7. We've got, at least we got cosine, so we don't have to convert it. But I'm going to rewrite the cosine squared as the cosine of x squared. And then we add 1 to both sides, so we get 4 cosine of x squared equals 1. We divide by 4, so we get cosine of x squared equals 1/4. Take the square root, get the cosine of x equals plus or minus the square root of 1/4. But the square root of 1 is 1, and the square root of 4 is 2. So we get the solution here, and so we have, again, like with the previous one, we have the cosine of x equals plus 1/2, or the cosine of x equals minus 1/2. So we're going to get 2 solutions from this, and we're going to get 2 solutions from that, and they're going to all be into the different quadrants, just like the previous problem. But these are the 2 equations, so that was step 1. Step 1, do that. Step number 2 is to find the reference angle. So again, depending upon which one we're doing here, but because, you know, the reference angle is the inverse cosine. I'm using inverse cosine because I've got the answer here, the equation in terms of cosine. So you take the absolute value of plus or minus 1/2. But since when you take the absolute value, whether it's positive or negative, you're still going to get positive. So you take the inverse cosine of just 1/2. Again, the reference angle is your first quadrant solution. Okay, so now we plug it into our calculator. So we'll get the inverse cosine of 1 divided by 2. And I get 1.047 radians x prime. Multiply and divide by pi. Divide by pi. You get 0.333 pi radians. And I'll convert this decimal into a fraction. So you get pi over 3 radians. Okay, so that's my reference angle. Step 3 is the quadrants. All students take calculus. So for the cosine, which is the trig function we're dealing with here, it's positive in the first quadrant, it's positive in the fourth quadrant. It's negative in the second and third quadrant. So the one where we have x equals or the cosine, using the original equation, cosine of x equals positive 1/2, we're going to get a quadrant 1 solution and a quadrant 4 solution from up here. When we had this, cosine of x equals negative 1/2, from there we'll get the second quadrant and third quadrants. So again, we're going to get a solution in each quadrant. Okay, so those are the quadrants. So now we need to figure out what the solutions are in those quadrants. So our quadrant 1 solution, the angle is the reference angle. Our quadrant 4 solution, our angle is 2 pi minus the reference angle. Our second quadrant solution is pi minus the reference angle, and our third quadrant solution is pi plus the reference angle. So one solution here is pi over 3, that's the reference angle. Our fourth quadrant solution is 2 pi minus pi over 3, which is 5 pi over 3. I just did that thing one problem ago. Here, the second quadrant solution is pi minus pi over 3, which is 2 pi over 3, 3 pi over 3 minus 1 pi over 3. And my third quadrant solution is pi plus my reference angle, so you get 4 pi over 3. So those are my 4 solutions in each quadrant. So then step 5 is to write them all out. So again, we take the solutions in each quadrant and we just add 2 pi times n to each one of them. And I just was going in some order here. It doesn't matter which one order you put them in. So when n is 0, so let's go ahead and write what n is. So when n equals 0, we get the 4 solutions from 0 to 2 pi. When n equals 1, we get the solutions between 2 pi and 4 pi, etc., etc., etc. Okay. Got one more on this page, but now here I have a problem because they're different functions. So if you could factor out a function, maybe that would work, but in this case you can't. But because they're squared, my first thought from my experience is you can use the Pythagorean identity. So you'll get sine squared of x equals 3. But remember, the Pythagorean identity says sine squared plus cosine squared equals 1, or the cosine squared equals 1 minus sine squared. So I'll plug this in, 1 minus sine squared x. And I'll come down here. So you multiply out the 3, so you get 3 minus 3 sine squared x. Add 3 sine squared x to both sides, so you get 4 sine squared x equals 3. So this comes to the other side, becomes positive. 3 plus 1 is 4. You get sine squared x equals 3/4. Sine of x equals plus or minus the square root of 3/4, which is plus or minus the square root of 3 over 2. So the square root of 3 is the square root of 3. The square root of 4 is 2. So we have two things we're going to look at. The sine of x equals plus the square root of 3 over 2. That'll give me 2 solutions, and minus the square root of 3 over 2. So that's step 1. Step 2 is to find the reference angle. So again, because this is plus and this is minus, the reference angle is just going to be the inverse sine of the absolute value of plus or minus the square root of 3 over 2. And when you take the absolute value of plus or minus, you just get plus. So we get x prime is the inverse sine of positive the square root of 3 over 2. So we go to our calculator. Inverse sine of the square root of 3 divided by 2, close parenthesis. We get 1.047 ... Multiply or divide by pi. We get 0.333 pi, or pi over 3. Just turned out all the problems I have reference angle of pi over 3. Okay, so that's the reference angle. Step number 3. All students take calculus for the sine. Positive in the first and second quadrants. All in the first quadrant. Sine in the second quadrants. Therefore, it's negative in the third and fourth quadrants. So, for this equation, the sine of x equals plus the square root of 3 over 2. That's first quadrant, second quadrant. The sine of x equals negative the square root of 3 over 2. That's quadrant 3 and quadrant 4. Okay, so that's step 3, was to figure out which quadrants are associated with which parts. Okay, first quadrant. The angle is equal to the reference angle. In the second quadrant, the angle is equal to pi minus the reference angle. Third quadrant, the angle is equal to pi plus the reference angle. And in the fourth quadrant, the angle is equal to 2 pi minus the reference angle. So our first quadrant solution is pi over 3. Our second quadrant solution is pi minus pi over 3, which is 2 pi over 3. Our third quadrant solution is pi plus pi over 3, which is 4 pi over 3. And finally, my fourth quadrant solution is 2 pi minus pi over 3, which is 6 pi over 3 minus 1 pi over 3, which is 5 pi over 3. So those are all my solutions. First, second, third, fourth quadrant. And then step number 5 is to just take all those solutions and add 2 pi in to each one. So the first quadrant solutions are that. The second quadrant solutions are that. The third quadrant solutions are that. And the fourth quadrant solutions are that, within going from negative infinity to positive infinity. Okay, the last one in this group. And actually, the next bunch are going to be easier because we only have to find what they are between 0 and 2 pi. So one more here. Where is it? Huh. Oh, keep going here. Oh, here we go. So here's a case where we can factor out a tangent of 3x. And so for this to be 0, for the product to be 0, each one of them, we set each one equal to 0. The second one, we'd say the tangent of x equals 1. If we solve for tangent of x. Here, we've actually got to do kind of a substitution. We'll say alpha equals 3x. So we get the tangent of alpha equals 0. And what's going to happen is, here we're going to get a solution, then we're going to take into account this 3x part. Here, this one's exactly the same as we've done before. So let's do this one first, and then we'll come back and do this one. So the reference angle here, let's call this B, part B, and call this part A. I guess I already did use A, but no, it's 9. So we're going to do the B part first. So the second step in the B part is to find the reference angle. So you'd say the reference angle is the inverse tangent of positive 1. Absolute value positive 1. Okay, well, the absolute value of positive 1 is positive 1. So let's take the inverse tangent here. So we take the inverse tangent of 1, and you get 0.7853. Reference angle is 0.785398. In this case, it's not going to be 1. Pi over 3 is not the answer. Okay, so we take that number and we divide by pi. And what we find out is we get 0.25 pi. So this number divided by pi is 0.25. Which is pi over 4. 0.25 is 1/4. So that's the angle. That's our reference angle. So step 3 for part B here is to find out what quadrants. All students take calculus. So for the tangent of x, it's going to be positive in the first quadrant and the third quadrant, and negative in the second, fourth. So because this is positive 1, we're going to have a quadrant 1 and quadrant 3 solutions. So step 4 is to find the solutions in quadrants 1 and 3. So in quadrant 1, the angle is equal to, did I use theta here, or x? I should have used x. Sorry about that. Let's put x. I guess it's because I used alpha here, but so this is x, 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 x. Okay. So x is going to be equal to the reference angle, which is equal to pi over 4. And the third quadrant solution, x equals pi plus the reference angle. So you get x is equal to pi plus pi over 4. And pi is 4 pi over 4. So just 1 is 4 over 4. So you get 4 pi over 4 plus 1 pi over 4 gives you 5 pi over 4. And I just realized we hadn't checked our answer here, so let's do that. Do the checking part here. Check. So if I take the tangent of pi over 4, I should get 1. So let's do that. Tangent pi divided by 4, and I get 1. Check. Okay, that's what I was looking for here. And if I take the tangent of 5 pi over 4, plug that into my calculator, tangent 5 times pi divided by 4, you get 1. So check, check. And then finally, step 5 is to find all solutions. So you take your first quadrant solution and you add 2 pi in, and you take your third quadrant solution, which is 5 pi over 4, and you add 2 pi n to that, where n goes between negative infinity and positive infinity. Okay, so those are the solutions for this part, B. So let's talk about A. So what we're doing is we're making up this variable alpha. And so using the same procedure, except in this case, we got to remember this is one of those cases where we're on the axes because it's 0. For the tangent, the axes are either 0 or undefined. So if you remember, the tangent of, say, theta is the sine divided by the cosine, or y divided by x. So the question is, where on the coordinate axes is y equal to 0 and x equal to 1? Well, it's going to be here, so that's 0, and over here, which is pi. Because here you have 1 comma 0, x, y. So, and over here you have negative 1 comma 0. So if you could also have a negative 1 in there if you wanted. So my two solutions, part 1 of this one, is going to be that x actually the part 1 is just that the tangent of alpha equals 0. If you were to find the reference angle, I guess you might be able to still use reference angles here, because the reference angle is 0. You know, if I were to take the inverse tangent of 0, absolute value of 0, what I would get inverse tangent of 0 is 0. Okay, so I get 0. So that's my my reference angle is 0 radians, which is also 0 pi radians. So you can think about, you know, if I had like quadrant 1 solution, it would say x is equal to x prime, which is going to be 0 radians. Okay, which is not really first, it's right on the edge of the first quadrant. And if you did the second quadrant, you get x is equal to pi minus x prime, reference angle. So you get pi minus 0, which would still be pi radians. So you can still use reference angle here, or you could use the unit circle to find the answers. So we kind of skip over the quadrant question because it's really not in a quadrant, and I've kind of done that already. So the solutions are 0 and pi. So step number 5 would say that x is 0 plus 2 pi n. That's my positive x-axis. And then I have pi plus 2 pi n as my other negative x-axis solution. So this would be 2 pi n, and this would be pi plus 2 pi n. So let's actually plot this thing and confirm that we've got all the solutions. So we've got these two solutions, and we've got the ones back here, those two. So let's just So what I'm going to do is I'm going to copy those so I have all of them all in the same place. Okay, so those are the solutions. Between 0 and 2 pi, you've got 0 pi, pi over 4, and pi over 4. And there's my equation. So we're gonna look at that. So what we have is the tangent of 3x times tangent x minus 1. Close parenthesis. And we'll go from 0 to 2 pi. 2 pi. So we graph that. So here are the solutions. So we got a solution at 0. We've got a solution here at pi over 4. I've also got one here at pi over 3. That was one I was not expecting. Here I have one at 2 pi over 3. Here's the pi solution. So what did I do wrong here? Or maybe I didn't go wrong. Let's see. So I've got the pi over 4 and the 5 pi over 4. Oh, I know what it is. Yeah, because I haven't finished yet. Okay. So so notice I forgot one step, which is this alpha equals 3x. So the way you handle that is when you get to this point. So we got to this point. Now those are with alpha. So really I put x here, but I should have been doing alpha. So this is alpha. That's alpha reference. So all these things become alpha. So in terms of alpha, these are my solutions. Alpha equals this. But alpha equals 3x. So if I plug that in here, I'll get 3x is equal to 0 plus 2 pi n. Or x is equal to 2 pi over 3 n. So just divide both sides by 3. And then I've got the second solution here, which is alpha equals pi plus 2 pi n. So I get 3x equals pi plus 2 pi n. If I divide by 3, I'll get x equals pi over 3 plus 2 pi over 3 n. And what will happen is, for the first 3 values of n, I will get solutions that are in 0 to 2 pi. So if I do n equals 0, on this one I'll get 0. Okay, so I get x times 2 pi over 3 times 0, which is 0. Okay, so that's the first one. If I do n equals 1, I'll get x is equal to 2 pi over 3 times 1, which is 2 pi over 3. And n equals 2, I get x equals 2 pi over 3 times 2, which is 4 pi over 3. Okay, so that's the 3 solutions between 0 and 2 pi that are associated with this first part. And then I do the second part. So I get x is equal to pi over 3 plus 2 pi over 3 times 0, which is pi over 3. I get n equals 1, which is x is equal to pi over 3 plus 2 pi over 3 times 1. So I get pi over 3 plus 2 pi over 3, which is 3 pi over 3. So I get pi. And then I have n equals 2, so I get x equals pi over 3 plus 2 pi over 3 times 2. So that's 1 pi over 3 plus 4 pi over 3. That's 5 pi over 3. So I've got these 6 solutions between 0 and 2 pi. So I've got those, plus I've got the ones that came from my other solution here, which was pi over 4 and 5 pi over 4. So let me put those in there. So I've got pi over 4 and 5 pi over 4. That came from the second part of the problem. Okay, now that I've got all these, let's, and I probably could put them in order. So let's do that. So we go 0, let's write them out in order in size. So you have 0, and then you have pi over 3. Oh, pi over 4 is for that first one after that. So we got pi over 4, pi over 3. Okay, let's mark those out as we get them. Pi over 4. And we've got 2 pi over 3, which is this one. The next one we've got is pi, I think. That's this one. Then we have 5 pi over 4. That's the next one. So that one there. Then we get 4 pi over 3, which is this one. And then we get 5 pi over 3. And then we start over again. So let's look at the graph now. And what's the best way to do this? Probably is just take a picture of this graph, put it over here, and then mark them off as we get them. And you're like, this is hard. Yeah, this is hard. Okay, I'm not going to give you one this hard, but it's one of these cases where I'm trying to show you. The procedure's the same. You just have to be very diligent. Okay, so let's go through here and mark these off. Okay, so here's my first solution, which I can't see right now. So let's move this over a little bit. Okay, this one is that one. 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 This one is that solution. This one is that one. This one is that one. And then we're back to 2 pi if we. So you see we did get them all, believe it or not. Okay, so these are the remaining problems. But there's one, I guess there's one word problem. The procedure here is exactly the same as we just did in the previous section. Actually, I guess there are some multiple angle things coming up here, which we've done one. We're going to do more of them. So, but in this case, we're just trying to find the solutions between 0 and 2 pi. So number 10, again, we can solve for the secant. So we're going to add 1 to both sides. We'll take the square root. So we get the secant of x is equal to plus or minus 1. And if you take the reciprocal, you'll have the cosine of x is equal to plus or minus 1. Now, because it's cosine or the sine, and if you get a 0 or 1 with the sine or cosine, that means it's going to be something to do with the coordinate axes. So we'll draw a unit circle here, and we'll draw the coordinates. So here we have 1 comma 0, here we have negative 1 comma 0, here we have 0 comma 1, and here we have 0 comma negative 1. So we've got the cosine of x equals plus or minus 1, and the cosine is the x coordinate, so it's the two solutions here are going to be 0. So x is going to be equal to 0, and x is going to be equal to pi. So I'm not using the inverse cosine. So anytime you see something where the sine of x or the cosine of x equals 0 or plus or minus 1, then the best thing to do is to think about the axes. If you also get the tangent of x equals 0 or it's undefined, these cases are when you don't need to use the inverse trig functions. You just need to think about the quarter points on this thing. So that is the solution. The solution also is 2 pi, but because if you go all the way around in the unit circle, you get 2 pi, but because of the parentheses here, a curved parenthesis, it doesn't include 2 pi. So the two solutions there are 0 and pi. And you can verify your results here. Or you could plot this function and see where it equals 0. So let's do that. Let's just do the plotting of the function. So it's secant of x squared minus 1. So we take secant of x squared minus 1. Plot that and look where it equals 0. So here, see it's 0 and at pi, and then yet 2 pi. So that's exactly what we just said, 0 and pi. Okay, so that one's pretty easy. Okay, the next one, you've got sines and cosines. So that means we've got to rewrite it so that it's either all in terms of sine or all in terms of cosine, and then possibly factoring things. So from my perspective, I think, okay, I can convert something that's squared into something that's the other function squared using the Pythagorean identity. So it makes most sense to think about that. So what we're going to do is we're going to write out the Pythagorean identity, and we're going to solve for the sine squared. So we'll get sine squared is 1 minus cosine squared. And then we can make that substitution. So you have 2 times 1 minus cosine squared of x equals 2 plus cosine of x. 2 minus 2 cosine squared of x equals 2 plus cosine of x. But we have a 2 on both sides, so we can get rid of those. Let's move the cosine to the other side, so they're all on one side. And we can divide through by -1, so it becomes 2 cosine squared plus cosine. And we don't have to well, we do factor, but we can factor out the common factor, which is cosine of x. So we get cosine of x times 2 cosine minus plus 1 equals 0. And so from that, there's two solutions. One is the cosine of x equals 0, and the one is cosine of 2 cosine of x plus 1 equals 0. Okay, this is one of those cases where we find things on the coordinate axes. So we'll just put our coordinates for those points. Those are easy. So you get 1, 0, 0, 1, -1, 0, 0, -1. So the cosine is the x coordinate. So this is one solution, and this is another solution. So from this, we can say x equals pi over 2, which is this solution, and 3 pi over 2. Okay, so that's half of it done. The second part is doing this one. Now, if you solve for the cosine of x, you'll get, first you'll get 2 cosine of x equals -1, cosine of x equals -1/2. Okay, so that's first thing, is solving it for the cosine of x. The second step in finding the solutions here is finding the reference angle. So we're going to say the reference angle is the inverse cosine of the absolute value of -1/2, which is the inverse cosine of 1/2. So we plug that into our calculator. Inverse cosine of 1 divided by 2, and we get 1.047 radians. And we take that number, 1.047, we divide by pi, and we get 0.333 pi radians, which is pi over 3. So that's my reference angle. Third step is to figure out what quadrant it's in. So you go back to this cosine of x equals -1/2, and you write out all students take calculus. And we're dealing with the cosine. So the cosine is positive in the first quadrant and positive in the fourth quadrant, but negative in the other two. And because we have a negative here, that means our solution is in the second and third quadrants. So with that piece of information, you can find the second and third quadrant solutions. Second quadrant solution, x equals pi minus the reference angle. So we get pi minus pi over 3. 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. So that's my second quadrant solution. And my third quadrant solution is x equals pi plus the reference angle. So we have pi plus pi over 3. 3 pi over 3 plus 1 pi over 3 is 4 pi over 3. So my final answer here, solution, now we don't have a step 5 because I'm just finding in between 0 and 2 pi, so we leave that off. So we got down here, we got pi over 2 and 3 pi over 2. So we got pi over 2 and 3 pi over 2. And from the second part we got 2 pi over 3, which I guess is here. 2 pi over 3. It fits right there. And then we have 4 pi over 3, which actually fits. So this one's a little less than, this is in the second quadrant. This is in the third quadrant. And then you have the negative y-axis. So those are the three solutions, and we're going to check out our answer here. So we've got where we're going to use, if we take the original form and just solve this. So we're going to have negative, or 2 sine squared of x minus cosine of x minus 2 equals 0. So I'm just taking the original equation and setting it equal to 0 by subtracting 2 and subtracting the cosine of x. So that's the graph. Let's just minimize this thing so I can see what I'm doing. So we've got 2 times the sine of x, quantity squared. Okay, so so we have 2 sine of x squared minus the cosine of x minus 2 equals y, and then we're going to look for the x-intercept. So we graph it, and we get that function. And so let's move it over here. Let's find out where are my solutions here. Okay, so they're the solutions. So we have pi over 2, which is right here. We have 3 pi over 2, which is out there, 2/3 pi. We have this one, which is 4 pi over 3. And we have 3 pi over 2. So there you go. I seem to know what I'm doing. Okay, so that was number 11. Number 12, we got this secant stuff. What we probably want to do is to somehow write that in terms of cosine, but we don't want to do it yet. We want to, because if we put in cosine now, we'd have 1 over cosine squared minus 1 over cosine, and that would just be crazy. So what we're going to do is we're going to take this equation, just subtract 2 from both sides to get it like that. And at this point we can factor it. So you'd have secant of x and secant of x. Why do I do that? Because I need secant squared of x. And then the two integers have to be 2 and 1. And one has to be positive and one has to be negative to get a negative 2. So because I have a negative secant of x here, I put the negative in front of the bigger one and a 1 in front of the smaller one, or the positive. Yep, or positive, and yeah, you see what I mean. So again, what we can do is we would get secant of x minus 2 equals 0. So we need this to go to 0 for the product to go to 0, and the other one is the secant of x plus 1 equals 0. So if we finally solve it for secant, we'll get the secant of x is 2. Now we'll take the reciprocal. Cosine of x equals 1/2 reciprocals. And likewise here, you'll do the secant of x equals -1 or the cosine of x equals -1. So the reciprocal of -1 is -1. So these are the two situations, and we said if the cosine or sine are -1, +1, or 0, then we are going to figure out where they are on the axes. So this has coordinate 1, 0, 0, 1, -1, 0, 0, -1. Those are the x and y coordinates of the coordinate planes. And you can see that this is the one that corresponds to that. X coordinate is the cosine. So what that means is x equals pi. When x equals pi, the cosine of pi is -1. Now here I'm going to have two solutions, and so now I go, let's just look at that case. Cosine of x equals +1/2. So that was the first step in solving these problems. The second step is to find the reference angle. So the reference angle is the inverse cosine of the absolute value of 1/2, which is the inverse cosine of just 1/2. So we go to our calculator. Inverse cosine of 1/2 is 1.047 ... radians. We divide that by pi, 0.333 pi, or pi over 3 radians. So that's my reference angle. Step 3 is, so that was step 2, find the reference angle. Step 3 is to figure out what quadrants. All students take calculus. Cosine. So cosine is positive in the first quadrant because they're all positive, and positive in the fourth quadrant, and negative in the second and third quadrants. So cosine of x equals 1/2 is going to be a quadrant 1 solution and a quadrant 4 solution. Quadrant 1, quadrant 4. And then finally step 4 is to find those two solutions. So my quadrant 1 solution says x equals the reference angle. So that's going to be pi over 3. And my fourth quadrant solution says you take 2 pi, subtract the reference angle. So you get 2 pi minus pi over 3. 2 pi is 6 pi over 3. 6 minus 1 is 5, so you get 5 pi over 3. So that's my fourth quadrant solution. That's my first quadrant solution. And then I have x equals pi is my x coordinate axis solution. So those are the between 0 and 2 pi. Those are my three solutions. So again, I'm going to go to my graphing program. I'm going to put in the original equation, which was secant squared x minus secant minus 2. So I can plot that. That's one of the functions I can't plot here. So I get the secant of x squared minus 2 times the secant of x. And what's the last thing? Oh, just secant of x, and then minus 2. So it's not 2 secant of x, it's secant squared of x minus secant of x minus 2 equals 0, but I set that equal to y. So let's double check this again. Let's move this over. Say OK. So we have secant squared of x. Okay, so that's, you can see here, secant squared of x minus secant x minus 2. So here are the solutions. Let's move this out of the way so we can look at, oh, here are where are my solutions? They're back here. Okay, those are my three solutions. So we go to here, the x-intercept is 0.33 pi, which is pi over 3. We go here, which is 1 pi, which is that solution. And then we have the third solution, which is 1.6 pi, which is 5/3 pi. So those are correct. Okay, next one is 13. We got secant x plus tangent x. When I saw that, I'm like, I'm not exactly sure how to do that. So I've had some time to think about this problem, and I never did come up with an analytical solution. You just have to kind of think about what the functions look like. So you kind of have to do a qualitative situation here. So remember, the secant function kind of looks like this, and the tangent function looks kind of like this. So there obviously is one point here, which is x equals 0, is a solution, because the tangent of 0 is 0 and the tangent of the secant of 0 is 1. Now what happens though is that this thing, the secant function, grows, but it grows slowly at first, whereas the tangent function grows more so rapidly. And as a consequence of that is that the secant is always, if you add these two together, it's always going to be more than 1. Okay. Well, actually, in this case, they're both positive, so they're both, when you add them up on this side of the origin, they're going to be positive, so there's no way they can equal 1. And in the case between negative pi over 2 and 0, the red function decreases more rapidly than the black function increases, and so it ends up that this is going to be negative. I don't think it changes quite as quickly. So let's open up my graphing program just to show you what the thing looks like. So what I'm going to plot is secant x and tangent x and secant x plus tangent x. And we just need to go between negative pi over 2 to positive pi over 2. And let's just graph this thing, see what it looks like. So let's change the view window here so that the x is in terms of pi. So the red curve is the secant, and the blue curve is the tangent, and the green curve is the sum of the two. So you can see the sum of the two is positive in the first quadrant from 0 to pi over 2, and it's between 1 and 0, except right here negative infinity. I mean negative pi over 2, because it goes to negative infinity. So that's why it looks kind of weird. So it's actually interesting. I made the comment about them, how quickly they change, but you can see that they're very close to each other. You know, the secant function is almost a mirror of the tangent function. Not exactly, but it's the difference between the two is minimal. And you can kind of see this too here, where if you look at the secant function and the tangent function, they're about 1 unit apart, but if you zoom out in the y direction, you can see that the values of the two functions approach each other as x approaches pi over 2. So that's kind of interesting. I did not know that. Anyway, the answer is x equals 0 for that one. But I couldn't think of any analytical way to prove that was the case. And I asked somebody else who would know, and they didn't know of any other way except to kind of reason through it. Obviously, I'm not going to put something like that on a test, because, you know, sometimes that takes insight or just luck to figure it out. Okay, 14. So here we have a case where we have secant and tangent, and they usually, especially if we have secant squared and tangent squared, we can either write it in terms of tangent or secant by using the Pythagorean identity. So we have the one that involves secant and tangent is tangent 1 plus tangent squared of x is equal to secant squared of x. So I'm going to plug that into here. So I'll get 2 times 1 plus secant, actually it's tangent squared. So secant squared is 1 plus tangent squared. And one of the reason to use tangent is because I don't have to use secant. You know, I have the inverse tangent function on my calculator. Okay, so what you'll get is 2 tangent squared plus 1 tangent squared. That's 3 tangent squared x. And then I'll get 2 minus 3, which is -1. So I'll get that there. I think we've seen this before in some kind of trig identity thing. Anyway, add 1 to both sides, divide by 3, take the square root, so you get the tangent of x is plus or minus the square root of 1/3. We've seen that before too. So the square root of 1/3 ends up being the square root of 3/3. So that's one of those things that we've seen before. And again, we're looking for solutions between 0 and 2 pi. So one of them is the tangent of x equals plus the square root of 3/3, and one is the tangent of x equals minus the square root of 3/3. Obviously these are going to have the same reference angle. This one will give us solutions in the first and third quadrant. You know, all students take calculus. So the tangent is positive in the first quadrant and the third quadrant. And the negative will give us the second quadrant and the fourth quadrant solution. But remember that we really only need the first and second quadrant solutions when it comes to the tangent. So we'll just get the first and second quadrant solutions. Well, they did say between 0 and 2 pi, so I guess we'll go ahead and do all 4 of them. If you're wanting to come up with the equation for all solutions, then you could just do the first 2 quadrants. And even if, you know, to find the 4 quadrant solutions, you do n equals 1, which n equals 0, which would give you these 2 solutions, and n equals 1, which would give you those. But we're just going to find all the 4 solutions for all the 4 quadrants. So the reference angle, which I'm using x, I remember to do it this time. So x prime is going to be the inverse tangent of the absolute value of the square root of 3/3, which is also equal to the inverse tangent of negative the square root of 3/3. That's why we only need to find one reference angle. So make sure our calculator is in radians. So we take the inverse tangent of the square root of 3 divided by 3, and we get 0.5236 radians. Keep that on our calculator. Divide by pi, we get 0.166 pi radians. So that's my reference angle. And then we can get all the solutions. The quadrant 1 solution says the angle is equal to the reference angle. So that's pi over 6. I forgot to write that down here. Pi over 6. Since 0.166 is 1/6. Okay, so that's my first quadrant solution. That's my from the positive the square root of 3/3. My second quadrant solution is pi minus the reference angle. So we have pi minus pi over 6, which is 5 pi over 6. So that's from the negative the square root of 3/3. Third quadrant solution, the angle is pi plus the reference angle. So that's pi plus pi over 6. So it's 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. That's from the positive over here. That's the third quadrant solution. And the fourth quadrant solution is 2 pi minus the reference angle. So you get 2 pi minus pi over 6, and that's 12 pi over 6 minus 1 pi over 6 gives you 11 pi over 6. That's from the negative the square root of 3 over 3. So we got two solutions in the first and third quadrant from the positive the square root of 3 over 3, and two solutions, one in the second quadrant, one in the fourth quadrant, from negative the square root of 3 over 3. Okay, let's move on to the next group. So these are some more multiple angle solutions. So this is where the alpha stuff comes in. So 15, we let alpha equal 2x. So now we're going to solve cosine of alpha is equal to 1/2. Now because it's cosine, we're going to find the two solutions between 0 for alpha and 2 pi, not including 2 pi. And then we can divide by 2 to get the x solutions. Okay, so now we're finding all solutions. So we're still going to find the solutions between 0 and 2 pi, and then we'll convert that to all solutions. So the first one is what quadrants? Which quadrants? All students take calculus. So we're dealing with the cosine. Positive in the first quadrant, positive in the fourth quadrant, negative in the second and third. It's positive, so it's going to be quadrant 1 and quadrant 4. Calculate the reference angle, alpha. So we're dealing with alpha here. Gotta make sure I do that. So alpha prime is the inverse cosine, whatever the trig function is we're dealing with, which is cosine. So it's the inverse cosine of the absolute value of 1/2. Inverse cosine 1/2. 1.047 radians. Or divide by pi. 0.333 pi radians, or pi over 3 radians. Okay, so that's alpha. That's the reference angle. Third step, find the solutions. So our Q1 solution says that alpha is equal to alpha prime, or pi over 3. Our fourth quadrant solution says alpha is equal to 2 pi minus alpha prime, the reference angle. So you get 2 pi minus pi over 3, and so that's 6 pi over 3 minus 1 pi over 3, that's 5 pi over 3. So that's my fourth quadrant solution. So in terms of alpha, alpha is equal to pi over 3 plus 2 pi n. That's the first quadrant solution. And then I have 5 pi over 3 plus 2 pi n. But alpha equals 2x. So that's 2x equals pi over 3 plus 2 pi n. So if you divide by 2, you get x equals pi over 6 plus pi n. And then the other solution, alpha equals 2x equals 5 pi over 3 plus 2 pi n. Divide by 2 and you get 5 pi over 6 plus pi n. And n in both cases is all integers. In terms of x, there will be 4 solutions between 0 and 2 pi, because there's 2 solutions in alpha, so there's 4 solutions in terms of x, and the solutions will be pi over 6, and then you'll add pi, so 1 pi over 6 plus 6 pi over 6 is 7 pi over 6, and then you'll add pi here, so 5 pi over 6 plus 6 pi over 6 is 11 pi over 6. So we're gonna plot this thing, the original one, and so the original function, we'll set the cosine. Yeah, what are we plotting? Yeah, well, we're gonna plot the cosine of 2x minus 1/2. Okay. Why did I do that? Because my original equation here is that the original equation is cosine of 2x equals 1/2, or I can plot the cosine of 2x minus 1/2 equals y, and that will, and then I look for the x-intercepts of that. Okay, so that's all I have to plot, and I'm going to go from 0 to pi, 2 pi, and I'll go from negative 2 to positive 2 because it's a cosine function. And what I should see is 4 intercepts. So you see here, there's one, put my cursor there, you can see it's pi over 6, here's 5 pi over 6, here's 7 pi over 6, here's 11 pi over 6. So that is the solutions. That's how you do it graphically. You solve this for 0, but then you set the equation equal to y and then find out where that function goes to 0, and then you can easily pick those off the chart. Okay, next one. So we have the tangent of 3x equals 1. So we'll let alpha equal 3x. So the tangent of alpha equals 1. So where does this happen? Well, remember, first thing we do, which quadrant? Which quadrants or quadrants? All students take calculus. Positive in the first quadrant, positive in the third quadrant, negative in the second and third. So we are going to have a solution in the first quadrant and a solution in the third quadrant. Now, because we're finding all solutions, we really only have to find the quadrant in the first solution in the first quadrant, and then we can add pi times n instead of 2 pi to n, because that'll give us our third quadrant solution. So this one's pretty easy. Alpha prime is the inverse tangent of 1. So I'll put that in the calculator. Inverse tangent of 1. And I get 0.7854 radians. Divide by pi. And I get 0.25 pi, which is pi divided by 4. So that's my reference angle. So to find my solutions to find my quadrant 1 solution, all I have to do is say alpha equals alpha prime. And therefore alpha, my first quadrant solution, is pi over 4. Then to find all of the solutions, I say alpha equals pi over 4 plus n pi. And this, you can only do this with the tangent and the cotangent. So if I let n equals 1, I'd get the third quadrant solution. So step number 5 for these multiple angle cases is you rewrite what you had originally, which is you said 3x equals alpha, but alpha equals pi over 4 plus n pi. So if we divide both sides by 3, we get pi over 12 plus n times pi over 3. So if we plot the function y equals tangent of 3x minus 1, where this goes to 0 are the solutions of this. And because we had 2 solutions between 0 and 2 pi, we should have 6 solutions, because we have 3x here. We should have 6 solutions between 0 and 2 pi. So, and the 6 solutions are going to be n equals 0, 1, 2, 3, 4, 5. Those are the, and so x. So when n equals 0, you get pi over 12. Then you have pi over 12 plus 1/3, which is going to be 1/12 plus 4/12. Is that right? Yeah, 4/12. That's 13/12. 13 pi over 12. Then you add. So we keep adding. Is that right? No, that's not right. So when n equals 1, we get 1/12 plus 1/3, which is 4. So you get 1 plus 4/12. So that's 5/12. And then you can see we just keep adding 4/12. So we'll get 9 pi over 12. 1 plus 5 is 1 plus 4 is 5. 5 plus 4 is 9. 13 pi over 12. 17 pi over 12. 21 pi over 12. If we did the 6th one, we would get 25 pi over 12, which is coterminal with the first one. So, and this is graded, 24 pi over 12 is 2 pi. So this one's outside of the interval we're looking for. And what are the decimal equivalents here? What's 1/12? It's 0.0833. This one would be that times 5. That would be 4.416 pi. These are all pi's. This would be 9/12 is 0.75 pi. 13/12 is going to be 1.08 something pi, 333. Here we have 17/12. 17 divided by 12 is 1.416 pi, and 21/12 is 1.75 pi. So let's graph this thing. What we're graphing is this original equation, tangent of 3x minus 1. Tangent 3x minus 1. Graph that. Okay. So we have 1, 2, 3, 4, 5, 6 solutions. That's what we expected. First one is 0.8 something, 0.08. The next one is 0.42, 0.75, 1.08, 1.4, 1.75. So those are all the ones that we said were going to happen. So that's good. Okay, so here we go, number 17. Now in this case, because we've got x over 2, we're actually going to have only one solution. And normally we get 2 solutions out, 2 quadrant solutions from 0 to 2 pi. But all we have to do to make this just like all the other problems is to define alpha as x over 2. So we have the sine of alpha equals negative the square root of 3 over 2. Step 1, quadrant. Which quadrants? So all students take calculus, so the sine, which is what we're dealing with here, positive in the first quadrant, S positive in the second quadrant, hence negative in the third and fourth quadrant. So we know that we have the third and fourth quadrant solutions. Calculate the reference angle. So x, oh, we're here, yeah, it's alpha. So we have alpha prime is equal to the inverse sine of the absolute value square root of 3 over 2 inverse sine of absolute value of negative square root of 3 over 2. So we take the square root of 3 over 2, take the arc sine of that, and we end up with alpha prime is equal to 1.0472 radians. Divide by that number by pi, and we get 0.333 pi radians, or pi over 3 radians. Okay, so step number 3 is to calculate the solutions. So we got a quadrant 1, quadrant 2 solution. So our quadrant 1 solution says alpha is equal to the reference angle. So alpha equals, oh, that, got something wrong here. Somehow I've moved these things around. Let me move this back, get it in the right place. Okay, now we're good. Okay, so we had third and fourth quadrant solutions. I got mixed up with the last problem. Okay, so we have a quadrant 3 solution. So that, in that case, we get our trusty formula out. Alpha equals pi minus the reference angle plus the reference angle. So you get pi plus pi over 3. So alpha, third quadrant solution, is 4 pi over 3. 3 pi over 3 plus 1 pi over 3. Our fourth quadrant solution says alpha equals 2 pi minus the reference angle. So we get 2 pi minus pi over 3. That's 6 pi over 3 minus 1 pi over 3. We get 5 pi over 3. So that's the fourth quadrant solution. So now we can write the solutions between alpha between 0 and 2 pi. Well, I just did that. So what we do now is we write it for all values of alpha. So we say alpha is equal to 4 pi over 3 plus 2 pi n. And our fourth quadrant solution is 5 pi over 3 plus 2 pi n. And then the final thing we do is we say x over 2 equals alpha, which is 4 pi over 3 plus 2 pi n, just from the previous step. So we multiply everything by 2. All these are the ones we divided by 2. So we get 8 pi over 3 plus 4 pi n. And our second solution is 5 pi over 3 plus 2 pi n, or x equals 10 pi over 3 plus 4 pi n, where n is all integers. So what I'm going to do is I'm going to plot from 0 to 4 pi, and the two solutions should be 8 pi over 3. So 8 that's 2.66, and 10 pi over 3 is 3.33. Okay. So what we're going to plot is sine of x over 2 plus square root of 3 over 2 equals y. So let me write that out. So the equation we're going to plot is y is equal to sine of x over 2 plus the square root of 3 over 2. Okay. Sine of x over 2 plus square root of 3 divided by 2. We'll go from 0 to 4 pi. We should have two intersections, which we do. Here they are. And the intersection is 2.66 pi, which is this 8 pi over 3. And the second solution is 3.33 pi, which is 10 pi over 3. Those are the two solutions for n equals 0. Now if I change my graph to 8 pi, graph that, you'll see there's two more solutions, and the distance from here to here is 4 pi. So I'm about 2.5 pi here. I get up to about 8.5 pi, or 6.5 pi, which is 4 pi. Okay, the last one's the secant. So we can rewrite this question in terms of the cosine. So the way we would do that to find the solutions, and we'll plot this, but I'm going to find the solutions using the cosine. So what it says is the cosine of 4x equals 1/2. These are equivalent to each other. So now, step 1. Step 1 I guess is alpha. Alpha equals 4x. So instead of solving the problem here, we're going to solve the problem cosine of alpha equals 1/2. So we kind of do two things. We replace the secant with the cosine, replace 4x with the alpha. Okay, quadrants. That's what that stands for. Okay, so all students take calculus. Positive in the first quadrant, positive in the fourth quadrant, negative in the second, third. So since it says positive, there's going to be quadrant 1 and quadrant 4. Okay, step 2, find the reference angle. Alpha prime equals the inverse cosine of the absolute value of 1/2. So if we take the inverse cosine of 0.5, positive 0.5, we get 1.047 radians. Alpha prime divided by pi, 0.333 pi radians. Reference angle, pi over 3 radians. Okay, so that's the reference angle. Step 3, Q1 and Q4 solutions in alpha. So quadrant 1 solution, alpha equals the reference angle, which is pi over 3. In the fourth quadrant, alpha equals 2 pi minus the reference angle, so we get 2 pi minus pi over 3. 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. Okay. so that's the fourth quadrant solution. Okay, step number 4 is to find the solutions between 0 and 2 pi for alpha. Oh, we did that. Step 4 is to find all the solutions. So all the solutions are going to be first quadrant solution plus 2 pi n. The fourth quadrant solution is going to be 5 pi over 3 plus 2 pi n. But what was alpha equal to? 4x. So 4x equals alpha equals pi over 3 plus 2 pi n. So if you divide by 4, you get pi over 12 plus 2 divided by 4 is half, so you get pi over 2 n. And then the second one, I'm just going to write it out here. You're going to end up with this divided by 4, so that's 5 pi over 12. So 5/3 divided by 4 is 5/12 plus pi over 2 n. So these are just these things divided by 4. So those give me the solutions, and I let n equal all integers. So we have two solutions in the original for alpha, but because we have 4x equals alpha, we're going to have 2 times 4, so we'll have 8 solutions between 0 and 2 pi for the original equation, which is, and what we're going to do is we're going to plot, the function we're going to plot is this y equals the secant of 4x minus 2. So again, I've subtracted 2 to get all the stuff on one side and set that equal to the function. So secant of 4x minus 2. Secant of 4x minus 2. Now if you use the graphing calculator, I don't know if you can plot secant or not. I don't think so. You'd have to do it in terms of cosine, but in this case you can. So 0 to 2 pi, we're looking for where this goes to 0. I said there should be 8 intersections, and you see there they are 1, 2, 3, 4, 5, 6, 7, 8. The first one should be pi over 12, which is 0.08 something. So there you go. The second one was the second solution was again when n equals 0, so you get 5/12 pi. 5 divided by 12, 0.4166. So this one should be 0.4166, which it is. And then you have these solutions are pi over 2 apart. So if I go from here to here, that's pi over 2 to here, pi over 2. Likewise, this one, which is my fourth quadrant, and this solution in alpha, you add pi over 2, you get that one, you add pi over 2, you get that one, you add pi over 2, you get that one. Okay, so I think that's it for most of the problems. Now we got one word problem, I think. Here we go. Okay. So we have this spring that oscillates, but it's not perfect. So it has this exponential term, which is what we call the damping term. Not damping term, but damping term. And the function is 1.56 e to the minus 0.22t times the cosine of 4.9t, where y is the displacement in feet and t is the time in seconds. Use a graphing utility to graph the displacement function from 0 to t equals 0 to 10. Find the time beyond which the displacement does not exceed 1 foot from equilibrium. So this is kind of just a graphing program example. And probably the best thing to do is to minimize this so I can see my equation entering it. So x goes from 0 to 10. Y goes, we have an amplitude here of 1.56 seconds, which will happen at t equals 0. So minus 2 to plus 2 seems like a good thing to do. With 1.56 times e to the minus 0.22, I don't have t, so I use x, times the cosine of 4.9 x. Let's make sure that's right. 1.56 e to the minus 0.22 t times the cosine of 4.9 x. Graph this thing. So there you go. So you can see it starts off oscillating and then it oscillates lower and lower and lower and lower. Now the intercepts are where the object goes through what's called equilibrium. What they're asking for here, if I draw two horizontal lines, one is y equals -1 and y equals 1, you see here I've got, so the question is find the time beyond which this displacement does not exceed 1. So this is positive displacement and it's exceeding 1. Here's negative displacement, it's exceeding 1, and if I zoom in on that little thing, that's the last time that it exceeds 1, because the next oscillation it'll be less than 1. So I just have to put my cursor there and look at the time, which is, well, let me change the view here so the x-axis and my cursor is in units. So it looks like 1.962. I could keep zooming in to get a better number. 1.96. Okay, so the answer is 1.96 seconds. T equals 1.96 seconds. So the question is, how would you figure that out? Because there's two things you could do. You could take the function I don't think you can actually do this analytically, and you would subtract, so we'll call this y prime. You could subtract 1 and find the intercepts of that, or you could add 1, so I'll call that double prime, and that would be for the lower intercepts, and then you'd find the, if you could find the maximum time where this intercept occurred, these two, the maximum one would give you it's not something you can do with what we know. It's just to demonstrate, this is an example of a real life situation, and in this case t less than 0 doesn't make any sense because it starts out at t equals 0, so we wouldn't want to pull out before 0. But you get, like I said, you get this thing oscillating, but it has friction, and so the oscillation gets smaller, smaller, smaller.